And then you just sign 18, but you're trying to sign everything. And that's a cross check. So you sign of 18.
Zach, did you throw an answer?
Yeah,
What'd you get?
so
20.4.
20.4.
All right, 20.4. All right, so again, so you got that scenario, and then it's not always going to be the same picture based upon the information you give it. So don't assume, like each time it's going to look like this. It all depends. It might be travel north to south, whatever. But like we said, just over here, this was north 72 degrees west. This will be 36 miles. This will be 75 degrees, and then that makes that 15. That makes that 18. And we do need to find this angle up here. And then 15 plus 18 is 33. Subtract that from 180, and we get 147. And then to find that value right there, that distance the second time, we do sine of 18 over x equals sine of 147 over 36. All right, minimum, make sure you show me your setup. You don't need to show me the particular details after this. I mean, if you want to, that's absolutely fine, but you don't need to show the cross multiplying and dividing. But I do need to see at least that setup. And then we divide by sine of 147. And then we said 20.4 miles, I think, for that. All right, could that figure have a second triangle? Okay, and here's one thing you got to watch is what we did yesterday. We said there could be 0, 1, or 2 triangles. That doesn't occur all the time. Don't get into the habit of thinking that everything could have 2 triangles. What's the only case it can have 2 triangles? Possibly. The only scenario. Okay. Well, it's bigger than H, but it has to do with like what initial size and angles you have. What initial size and angles you have.
Angle, side, side.
Angle, side, side, which I'm going to say side, side, angle, because I don't want to be bad like that. Side, side, angle. Is this a side, side, angle situation? And that's what you have to be able to tell me. We know we were given 2 angles. We found the third, and then we were given this side. You only have one side. This is not a side-side angle case, so it cannot have another answer. It's just going to have that one answer. So that's probably the biggest thing is once we do this, everybody, you want to think everything has 2 triangles. That's not the case. Only side-side angle, okay, for that. All right, we're going to finish up those notes. Any questions, though, on that, setting that up? Today's homework will be the last homework on the 9 weeks. And then if there's like, if you were absent or you had anything else that's out or you want to double check it, make sure you get that done. And then I'll drop your lowest homework. What's today? Tuesday. So I'll probably drop it either tomorrow or Thursday. And then basically you finalize your grades. And I'll kind of let you know where you are CCP wise, hopefully this week for that. All right, just a quick review from yesterday. Cole, Emily, this is kind of where this comes from. If this angle A, if I keep this the same, this side cannot change, this length cannot change, and we showed yesterday that, all right, those are the same, right? And then what did I do? I flipped it. And then if I draw this here, what I can do is I can create a second triangle that has those same dimensions. So this angle, that side, and that side are all the same, but are those 2 triangles the same? Clearly not. They're clearly not. Now here's the big thing that comes up, and this is going to how to determine whether we get 1 or 2 triangles. This initial angle, this angle here, let me call it X, is going to be related to this angle. Okay, this angle is always going to be 180 minus whatever that is. So you're going to find, this is the only angle you can find using the law of sines. If there's a second triangle, it's going to be 180 minus that. Because we said since these are the same, since these lengths are the same from geometry, these angles have to be the same. And that means that this angle here is gonna be, if this is X, that this angle here has to be 180 minus X. Okay, so long story short, once you find the first angle, we're gonna do 180 minus X. Okay, we said that you can take a look at the height. Not many people do that because typically you just go to solve it. But if you look at the height, that tells you also how many triangles you have based upon that A value. First case here, what did we get? We got an error message. We said there were no triangles, right? I think we did that one. Second one, we got one triangle, right? All right, so I don't think we finished the other one. Okay, so next one here. All right, I'm going to spoil it. There will be two triangles, of course, but did we copy down at least the information? Yeah. All right, so we got the information down. So A is 47 degrees, side A is 11, side C is 13. All right, so we have that. This is 47. A is 11. C is 13. And now I like to draw a side-side angle in this form because this is the easiest for me to kind of recognize whether there's two triangles. Whoops, I don't want to flip. And it's easiest for me because here's what can happen. This is the side that will switch. Like if I can view that, it's just easier for me. Well, what's the only thing, given the information I have, the only thing I can find right now? Okay, using wall signs, using anything. This one. Angle C. Angle C. So let's find angle C. I don't think we did that, did we? All right, go ahead and find angle C. And so angle C, so we take the sine of 47 degrees over 11 equals the sine of C over 13. Now, when you're finding the angle, you gotta use inverse sine. I'm gonna go through the steps here. 13 times sine of 47 equals 11 times sine of C. Divide by 11. And then I get angle C equals the inverse sine of that whole mess. 13 times sine of 47 over 11. So what do we end up with for that? You got that? 9.8? 59.8. I didn't think it was 9.8. 59.8. I think one agree. We agree? We agree. 59.8. All right, good. Here's what I'm going to tell you to do. At this point, you don't know whether there's a second triangle. If you get an answer, you're guaranteed there's at least one. Here's what I'm going to tell you to do is go ahead and say, assume there's a second triangle and say, so for triangle 2, at whichever angle you find first, you immediately find the other angle in triangle 2. So angle C is going to equal 180 minus 59.8. And what does that equal? Angle C equals, what is that, 120.2? So here's the test. That angle and the original angle, add them together. Are they less than 180 or more than 180? If they're less than 180, we got a second triangle. So it is a what, 167. That guarantees we got two triangles. So at this point, I'm going to list everything for both of them. I'm going to say, here's triangle 1, here's triangle 2, and I'm going to list even the ones we already know. Angle A, angle B, angle C, side A, side B, side C, and I'm going to do it for both. Angle A, angle B, angle C, A, B, C. And then fill in like the given. What was the given? A, it was A 47?
Yeah.
A was 47. Side A was then 11, I believe. Yep, and then side C was 13. These cannot change in those two triangles. These cannot change. But we found angle C to be 59.8. We found angle C for the other one to be 120.2. And now make sure you don't intermix now. Just treat totally different. So you get triangle 1 on the left, you get triangle 2 on the right, you get two different values for everything else. Now find an angle B. That's just adding them up and subtracting from 180. And then we're going to find side B. So 180 minus 47 minus 59.8. And that gives me 73.2. Let me put this in red, 73.2 degrees. All right, now to find side B. If it helps you to look at the figure, this is 73.2. What do we say this was? 59.8. And then B is across from here. I got to use a 73.2. Theoretically, you could use either one. What I suggest, well, let me tell you, use the one that's not rounded off. Okay, so let's use angle A and side A. So use those because they're not a rounded off value. So I'm going to set this up as sine of 73.2, sine of 73.2 over B equals sine of 47 over 11. And now 11, and then cross multiply. This time you don't have to do the inverse because you're not looking for an angle. We'll use the inverse sign. Ty Walker, let me know what you get there for B. 14.4. We got agreement? 14.4. Now that would be your first triangle there. Second triangle, we got to take 47 and then 120.2. Take those away from 180. So 180 minus 120.2 minus 47, 12.8. And I'm going to do the same thing. I'm going to take the sine of 12.8 over B equals the sine of 47 over 11. And then figure out what B is. Okay. What is that one? Sydney, you got it yet?
I got 3.33.
3 point, yeah, we're just everything to the nearest tenth is fine. 3.3. That's fine. All right, agree. And let me go back to, let's see, will this work? Yeah, it works somewhat. So this is 47. This angle is still 47. The side across is still 11. This is 13. But angle C and angle B definitely have changed. And side B has definitely changed. So angle C is 120.2. Angle B is 12.8. And then we got 3.3 here. So hopefully it makes sense that I can still have one angle and then the two sides the same, but I have two totally different triangles. Okay. And you don't know which one you're dealing with until you draw out the situation. All right, let's just take a look at one more. And all I want to do is get enough information down to say whether there were 0, 1, or 2 triangles. That's all I want for this one. Now, we are going to have to calculate a couple things. But whatever works. So copy that down, and I would even draw the figure. What would it look like? All right, so angle B, and I'm gonna put that, no matter which angle they give me, I'm gonna put it in the bottom left. If I only have one, that's 54. And then side B is 14, and I'm gonna put 8 over here. The only thing I can solve for is angle C, so go ahead and solve for it, see what you get. Okay. And so I get sine of C over 8 equals sine of 54 over 14. Do your work, inverse sine. Catherine, let me know what you get.
I got 27.5.
All right, 27.5. Do we get one? Do I get a second? Anybody second that? Yes. So 27.5. I at least need to know that. So here's what I'm going to say. So for triangle 2, angle C is going to equal 180 minus 27.5. So angle C is going to equal 152.5 degrees. Is that possible? That is not possible, because what's our other angle given to us? Our other angle is 54. Those add up to clearly more than 180. So that means that this will not work. If I get an answer for this one, that means I have to have one triangle. Oh, that's a bad box. There we go. One triangle. Okay. So to me, it's a little bit easier just to go ahead and calculate that angle, do 180 minus that, figure out whether I got a second triangle. There's other ways. Yeah, you can do other ways just to figure out 0, 1, or 2. All right, I want to give you a good amount of time in class. Look, 86 and 92 are word problems that take a little bit of, thinking to get through them. The other ones are just like we did in class. Figure out whether it's 0, 1, or 2, solve them. I got the answers to the even ones up front. So if you want to double check, come see me, check the odds, but use this time wisely, get as much done here as you can. If you want to work with somebody, that's fine, as long as they're not going to hinder your progress. And for 92, I kind of spilled it. There's 2 answers. Okay, there should be 2 values. I think they're asking for times. There's 2 times. Because you can make 2 triangles from the insult.